Good afternoon, guys. So welcome to today's session. So in previous sessions, we have seen K-means clustering, right? So we have seen what was our motive, why we did K-means clustering, and right. So today we'll be doing KNNs. Okay. So we'll be seeing supervised learning. So in yesterday's session, we have unsupervised learning, right? So what is supervised learning? We have seen uh, why we need unsupervised learning. Okay, I have given you the complete details. Okay, so what is K-means clustering and how did we perform the data? Okay, why did we need that? So why did we need to do K-means clustering? We have seen them. Okay, so today's topic is all about KNN. Okay, in K-means we have done clustering. Okay, in K means we have done clustering. So today we'll be seeing what is the thing. Okay, what is KNN? So what we are going to do here. So what is the data set we are going to use for KNN? Okay. So guys, as we move on, we'll be seeing K nearest neighbor. So introduction guys. So what is our agendas today? So our agendas is we are going to see the introduction, KNN in machine learning, importance in automative analysis, and conclusion. So guys, we'll be covering this all the topics. Okay, so we'll be covering all the topics, introductions as well as KNN in machine learning, and we'll be seeing what is the importance of this automative analysis and what is the conclusion we are going to get. Okay, so moving on, guys. As I said, we are going to see introduction. So what is this KNN? So guys, KNN, K nearest neighbor, okay, is one of the simplest machine learning algorithm based on the supervised learning technique. Okay, so KNN is nothing but guys, it is one of the simplest machine learning algorithm based on supervised learning technique. So guys, this K means what the clustering, what we did was right. That was all about unsupervised learning. But K nearest neighbor is of supervised learning techniques. Okay. So today we'll be seeing supervised learning technique. So what is this KNN? How it works? Okay, guys. So I said we'll see the introduction. KNN works by finding distance between a query, okay, and all examples in the data. Okay, selecting the closest of the query, votes for most frequent label. Okay, depending on this, how this is KNN is gonna work. Okay. So guys, KNN algorithm assumes the similarity between the new case data, available cases, and put the new case into category that is most similar to available categories. So guys, what is this in the sense makes? So guys, this KNN algorithm is gonna get to the data which is very near to them. Okay, so that is the reason we are going to use KNN algorithm. Okay, KNN algorithm stores all the available data and classifies a new data point based off the similarity. So this KNN guys, the algorithm what we are going to use right for supervised learning technique, it's going to classify all the points based on what the similarity we're going to get. That means when new data appears, then it can be easily classified into a good suit category. So while explaining furthermore, well, we go more deep, right? So I'm going to explain you what is the sentence. Okay, is all about saying. So guys, this K means and clustering. Okay, you should not always get confused here. K means is always about unsupervised learning. Okay, we know what is meant by unsupervised learning, right? It is unlabeled data. So the example is where a person learns himself. Okay, the person learns himself. It is known as unsupervised learning. So supervised learning is nothing but a teacher teaches him and the student is going to learn. That is known as supervised learning. Okay, the teacher is saying learn, the pressure is there. Okay, learn. That is called as supervised learning. Okay, so and it is a labeled data. Okay, unsupervised unlabeled data, supervised learning is labeled data. Okay, so this KNN algorithm can be used for regression as well as classification. Okay, guys, this KNN algorithm has two types. One is regression and is classification, guys. So, but mostly, if you ask, so which we are going to use mostly often in all the real-time industries, we're going to go for classification problems. Okay, so as I said, we have two algorithms like the KNN has two algorithms. One is regressions as well as classification, right? So what does this K mean? So I'm saying K nearest neighbor, guys. So let me write it K N, right? So what this K indicates in this KNN, guys? Okay, so let me undo this once. Okay, so What is this K? Okay, in KNN. What is this K in KNN? So guys, they're often, okay, they're basically confused with each other. Okay, the K in K means the K in K, this K means this it's nothing but KNN algorithm. Okay, so K means clustering is an unsupervised learning. We know that, right? So K means clustering is an unsupervised learning algorithm that is used for clustering, whereas KNN is a supervised learning algorithm used for classification. You guys, so I'm not only talking about KNN here, I was talking about K means. Okay, so the K in K means, okay, the K in K means clustering. The K means clustering, right? So let me write it down for you. So the K means clustering. So guys, the K means clustering. Okay, the K means clustering has nothing to do with the K in KNN algorithm. Okay, this is different. This is different. Okay, K means clustering is an unsupervised learning. So please remember that, guys. So K means clustering is an unsupervised learning. Okay, it is an unsupervised learning that is used for clustering. Okay, this is used for clustering. So I have done K means clustering, whereas KNN is a supervised learning method used for classification. Okay, guys, this is used for classification. So these things we have to keep in mind, guys. Okay. So if you ask me, is KNN a learning algorithm? So guys, the K nearest neighbor classifier, nothing but KNN is a non-parametric supervised machine learning algorithm. Okay, it is based on distance-based class. It is based on distance. Okay, it classify objects based on their like I can say neighbors classes. Okay, this KNN is most often used for classification. Okay, and but can be applied to regression problem as well. So as I said, regression as well as classification. Most probably we are going to use for classification. Okay, why KNN is a lazy learning? So as I said, guys, why this KNN is a lazy learning means, because it does no training at all. Okay, when you supply the training data at training time, all it is doing is storing the complete data set, but it does not do any calculation at that point. Okay, so at training time, all it is doing is storing the complete data set, but it does not do any calculation at this point. Okay, why KNN is like supervised or unsupervised? We have seen it, right? So if you ask me, sir, can you give us what is the basic concepts? Okay. Basic concept, okay, of KNN. What is the basic concept of KNN? The K nearest neighbor algorithm is also known as KNN. As I said, it's a non-parametric supervised learning classifier. Okay, basically it uses proximity to make classifications or predictions about the grouping of an individual. Okay, so the basic point is it is known as non-parametric supervised learning classifier to make classification or predictions, the grouping of an individual data. Okay, so guys, this is all about thing. And if you ask me, sir, which is the better algorithm, right? The doubt arises, sir, which is the better algorithm? So while both algorithms yield positive, okay, so we're gonna see a supervised learning method where student learns and teacher is gonna teach and student is gonna learn. Okay, that is called as supervised learning. Okay, so K nearest neighbor is all about that. So the KNN guys, how this KNN in machine learning is gonna work? So we have simple steps, guys, which should be followed. Okay. So the KNN can be explained on the basis of below algorithm. So guys, it has some steps which should be followed, and we are going to select the number of neighbors, and we're going to calculate the Euclidean distance. So what is Euclidean distance? It is nothing but between centroid value and observed value. Okay. So the step 3, we are going to take the k nearest neighbors as per calculated Euclidean distance. So I am going to explain you about the concepts of k. So we're going to take some examples. We are going to see that. Okay. Among those k neighbors, count the number of data points in each category. Okay. And we're going to assign the new data points on the category for which number of neighbors is maximum. Okay. So after following the 5 steps, the next step is our modulation. So basically, guys, we're going to select the number of k neighbors. Okay. So I'm going to say the k neighbors is k is equal to 3. Okay. And I'm going to calculate the Euclidean distance. Okay. So how to calculate an Euclidean example, right? So I'm going to explain you that about that. So guys, this k means k and n. K means clustering. Okay. So both are different. So we're going to see, as I said, we're going to see k and n. So the steps what we have to follow are these 5 steps. If you follow the 5 steps, what we're going to do, that is enough. Okay. So let me say the example, I have gotten result of k is equal to 3. Okay. So let me explain you with some examples. We're gonna get an idea of k nearest neighbors. Okay. So I'm gonna say k nearest neighbor classification. Okay. So let me write it down. Neighbor classification. Okay. So this is you are gonna see, guys. So let me go to the new page. So guys, so let me say I have gotten an example of k and I'm going to explain. So I have got something. So they have given a query. So they have said me, let me say the results are out for this engineering. Okay, the results are out for some computer science students. Okay. And they have given max is equal to 6 and CS is equal to 8 and K is equal to C. So they have said me to check the students who have passed and who have failed. So using this K and N, we are going to see how we are going to implement. Okay, using Euclidean distance. So we have 2 things, guys. One we can use, okay. One we can use Euclidean distance. The next we can use Manhattan. Okay. So now I'll be using Euclidean distance, guys. So we'll be seeing. So as I said, max is equal to 6. So they have said max. Okay, so let me write it in different color. So the math, the code is 6, 7, and 5, 8. Okay, and the CS result. Okay, so how this KNN is going to work? How it's going to track K nearest neighbor. Okay, what is mean by that? I'm going to explain this. Okay, next one is CS. Okay. And I'm going to write something like numbers 3, 7. Okay. Okay, so we'll be seeing this. So let me write it. So I'm going to take so 4. I'm going to take 4, 6, 7, 5, 8, and I'm going to take for CSE. So I have got a query. They are going to say whoever's values are matching where K is equal to say 3, they are passed. Okay. So how to check that using K nearest neighbor? We are going to see. Okay. So we are going to see that how we are going to do that. So guys, So this is a table what we have. Okay, so they have given a query. The results are out for computer science, the BSc students. Okay, the BSc students, computer science, the results are out. They are saying max and CS, they have got these students have got these marks. I need whose values are near to 3. I want to consider them as pass. Okay, so what I will do? So we have an Euclidean distance. So as I said, I'm going to use Euclidean distance. We have Euclidean distance. Okay, so Euclidean distance square root of summation of x1 minus xa1 square. So I'm going to explain what is meant by this. And next we have is okay. So this xo is nothing but observed value. Okay, observed value, and xa1 is actual value. Okay, so what is my observed value? My observed value is 3, right? And actual value is 4. So try to remember that, guys. So then this, let me explain new page. Okay, so I'm going to explain the same thing, right? So let me zoom it and explain here, guys. Okay. Okay, so let me explain here. So it will be easy for you. So guys, as I said, BSc results are out. So they have given K is equal to 3. Okay, they have said K is equal to 3. Okay, they are saying I want the values which are near 3, they are passed. So what results we have? We have here is, so the query what we have got is, so I'm going to explain K and N. So okay, so the query what I have got is x is equal to max 6. Okay, and CS is equal to 8. Okay, okay, CS is equal to 8. So I'm going to change what is that. CS is equal to 8. Okay, the query is this. So now we have got a table like they are saying max. We have 5 tables, 5 students. Okay, max 4, 6, 7, 5, 8. So I'm going to take this, and CS we have is 3. Take some numbers. Okay, these tables we have. They are asking us what is the result they are getting. Okay, so they are asking us to give the result. So we are gonna see what is the result we are gonna get using this thing. Okay, so here we have 2 things. So for K and N, we can use Euclidean distance and we can use Manhattan. Okay, so guys, the formula for Euclidean distance. Okay, so what is the formula for Euclidean distance, guys? So the Euclidean distance, I'm going to use Euclidean distance here. So D is equal to x1 minus square plus xo2 minus, so let me add it, plus, so the formula will be D is equal to square root of, okay, plus xo2 minus xa square, xa2 of square. Okay, this will be our formula, guys. The formula for Euclidean distance. Okay, so between this is observed value and this is the actual value. Okay, observed value and actual value. Observed value and actual value. Okay, guys. So this thing we are going to see. So how we are going to get the result? So K nearest neighbor, the things which are near. Okay, things which are near K is equal to 3. Then we are going to call it as the result or pass or fail. Okay, using this. So let me explain. So as I said, between observed value and actual value. So what is my actual value? 6. Right. So I'm going to use Manhattan distance, guys. So I'm going to write 6. Okay. Minus what is my observed value? 4. 4 of square plus what is my actual value? 8. 8 minus what is my observed value? 3 whole square. Okay. So what is the result we are getting, guys? So here, first one, this is first one. So what is the result we are getting here? So 6 minus 4 is nothing but 2 and 8 minus 3 is okay. 2 square plus 5 square. Okay. This is nothing but root of 29. Okay. Root of 29. And root of 29 is 5.38. Okay, guys, is that perfect? First thing. So what I have done, observed value and actual value we have taken. Okay. So what is my observed value here? My observed value is 4. Okay. And my actual value is 6. Okay, this is my actual value, yes. And this is my observed value. Okay, let me write it. This is observed. And this is my actual. Okay, so what is my observed value? Observed value is this thing and actual values. Okay, the same thing we have done this. So after that, so next thing we're going to perform for second one thing. So what we have 6 minus 6, right? Actual value and observed value whole square. So see 6 of 6. Okay. And after that, so guys, here it is. Okay. So this is actual value. So you get confused. This is actual. This is observed. Okay. For your understanding, it is better. Okay. So, and the next thing, what we are going to do, 6 minus 6 is done. Plus, again, actual value and observed value. So, my actual value is 8 and observed values. Okay. So we'll be doing this. The square root of 6 minus 6 is 0. Okay. And what is the answer? So here, what is the value we're getting? 0 plus 1 square. So what will be the answer? 0 plus 1 is nothing but 1. Okay. And the next thing, the same thing we are going to do for everything. Okay. So the third one, what we are going to do, what we are the formula of between observed value and actual value. Okay. So again, actual value and observed value. Actual value is 6 and my observed value is 7. Okay. Whole square plus again actual value minus observed value. So 8 minus 8 is nothing but same thing as 1. 6 minus 1 is 1. 8 minus 8 is 0. 1 square plus 0. 1 plus 0 is 1. Okay. The next thing we're going to do the same thing. Square root between actual value and observed value. Okay. So it is nothing but 6y minus 5 square plus 8 minus 5 square is equal to what is the answer we're going to get? We're going to get root 10. So for that it is 3.16. Okay. So guys, let me zoom out a little bit. Okay. So this is done. And the fifth one, guys, what we are going to do. So what is the fifth one? We have observed value and centered value again. So 6 minus 8 square plus 8 minus 8 square. So what is the value we're going to get here? 2, guys. So now, what is the answers we are having? So we are having the answers as 5.38, 1, 1, and we have 3.16, so guys, what is the nearest value for this? Okay, the nearest value, if you ask me, without having any decimal points, okay, 1, 1, and 2. Okay, so guys, what is the nearest value? 1, 1, and 2, right? So this is the far more than that. It is actual value is k is equal to 3. They have given the query. Is that bigger than that, right? 5.38 is bigger than that, and 3.16 is also near. So what the result will come? First thing is 5.38. Of course, it is not nearer to 3, or it is not this thing. So what is the result? The result will be fail. Okay. And now the second thing we have is 1. So 1 is near to 3, guys, the stepwise. Okay, only one step. So that is pass. And the identical, the next thing is also done. And the next thing we have is 3.16. So guys, as it is in decimal, so we are gonna consider it as not near to 3. So we're gonna consider it as fail. And the 2 is also near to 3. After 2, only one step, right? So that time what we'll do, pass. So guys, what is the k is equal to 3? So these many students have passed and these many students have failed. Okay, this is how we are gonna take k and n, guys, the nearest neighbor values. Okay, this is one method. So I'm gonna explain you one more different method how we are gonna calculate. Okay, what is meant by k and n? We're saying k nearest neighbor. Okay, so how to do that? We'll be seeing. So guys, this is one example. So what I have done here. I have got a query. Okay, so they are saying max is equal to 6 and CS is equal to 8, and they are given the k is equal to 3. So using this, they are saying, can you calculate how many students have passed and how many students have failed? Okay, the nearest value what we are getting, they are passed. Okay, the grading is 3. What they are getting, if they are getting k is equal to near to that, they are passed. Okay, so the query is we have got this table. Okay, CS and max. Okay, so we have used Euclidean distance there, actual and observed value. So x naught 1 plus xa square plus x naught 2 minus xa 2 of square. So square root of that we are going to do. So actual value and observed value we have taken here. Okay, again actual value and observed value. We have squared that, and after that we have done a square. So after that we have got an answer like this. Okay, same thing we have done for everything. We have took the square of that and we have done a square root. Okay, guys. So these answers we are getting. After that, we are going to do how it's going to move, right? So wherever there is nearest value, then we are going to call it as KNN. Okay, KNN nearest name. So this was done, guys. So let me give you one more example of K. Okay, so let me explain you the slide. So guys, let me say there is a graph. Okay, there is a graph, there is a pointer like this. Okay. Okay, so here we are gonna find out which is the k nearest. So which value is near to this? Is it gonna belong to the blue stage? Okay, is it gonna belong to the blue thing, or it's gonna belong to the red group? Okay, we have two groups. One is, okay, let me write it. Blue group, and we have red group. Okay, so we are gonna see which group this pink belongs. Okay, so guys, how we are gonna do that? So we are gonna do that based on which is the points which is most nearby to this pink. Okay, which is very nearest to it. So we can count 1, 2, 3. Okay, these things are very near. So here only one group of red is near to the pink. So guys, the majority the blue thing is gonna take. So it belongs to the blue group. Okay, so it is simple explanation, guys. We're gonna see who has the more thing. Okay, so basically we're gonna see how many points are near to this pink value. Based on that, we are gonna say so it belongs to this value. Okay, guys. So this was all about this. Okay, so let me explain some slides. So going back to the, so we have seen introduction and we have seen how K and N works. Okay, so we have seen select the number of k neighbors, right? So the number of k neighbors. So let me. So I'll explain this guys in some different thing. Okay. So select k of the neighbors. So I'm going to do it once again. Select k of the neighbors. Select number of k neighbors. Okay. After that, calculate the Euclidean distance and take the nearest neighbors as per calculated Euclidean distance. And after that, among these k neighbors, count the number of data points in each category. So we are going to calculate the number of each category that is present. Okay. And after that, we are going to assign the new data points in the category for which number of neighbor is maximum. Okay, guys. So I'm going to show you how it is done. So the next question is, why do we need KN in algorithm? Right. So why do we need that? So guys, why do we need KN in algorithm? So suppose there are two categories. Okay. Suppose there are two categories, category A and category B. We have a new data point x1. So as I explained, guys, we're going to calculate this point, which is how many data points are near to them. Okay. So to which category it belongs? Is that belonging to category A or belong to category B? Okay. So we have a data point. We're going to see to which category it's going to belong. Is that going to belong to category A or is that going to belong to category B? So how we are going to do that? We are going to calculate how many data points are near to them. Okay. How many data points are near to them. By using that, we are going to see which category to it belongs. So you can calculate all the data points, guys. You can see these data points are very near to them, right? The data points are near. See the distances. The category 8 is different. So it belongs to category A, guys. So that is how we are going to see how K and nearest neighbor calculates. Okay. So let me show you. So this is one more method, guys, where we can see K nearest neighbor classified. Okay. So we are going to see which data points in this data point, which where we have the nearest neighbors. Okay. We have three stages. We are going to see which data points which is near. Okay. So this is the data point. Okay. So we can see the data points which are near. So you can see, guys, we have three categories. Okay. So if we have multiple variables, guys, okay, multiple data points, then it will be a problem. Okay. So nearest neighbor classifier. So guys, as I explained you, we have some steps for nearest neighbor classifier. The first thing is select the k number of classifiers, calculate the Euclidean distance, take the k nearest neighbors. Among the k neighbors, count the number of data points. After that, we're gonna assign the new data points for each category. It's gonna bring. Okay. So how we are gonna select k value? Okay. So how we are gonna select the k value? So if k is equal to 1, classes are divided into regions and the query belongs to class recording in their region. Okay. Choose odd values of k for a two-class problem. That is done. K must not be a multiple of the number of classes. Okay. So here we have one data point. Okay. We have the data points here like red we have, and we have nearest neighbor like blue we have, and if we have one more nearest neighbor like this. So what is the nearest? It's going to take the nearest value, right? K means it's going to take the nearest value what will. So guys, if we do like this, if it has multiple number of classes, then it is not equal to this. Okay. So that is one reason we should not have multiple data points. Okay. So that one thing is restricted for KNN. So we're going to see how K nearest neighbor classifier works. Okay. So guys, you can see we have a data point here. Okay, as I said, we have two stages here. This is stage one, okay, and this is stage two. So we have stage one and stage two. Okay, so we have data points. So we are going to see which is the nearest neighbor classifier. Okay, so we are going to see which is the nearest neighbor classifier. So the data points as took this, so we can say this was the nearest neighbor. So you can see, guys, this all distances are far, right? So only this distance is nearer. Okay, only this distance is nearer, and all the remaining points you can see as I draw the lines, you can see the distance is too far, right? You can observe and you can see. So this is one thing, guys. Okay, it's gonna take only the nearest neighbor. Okay, it took first point, and next thing it's gonna go for second nearest neighbor. So guys, here after that, okay, so let me draw like the lines and keep it so I understand it easily. So let me draw the lines, guys. You guys, so we'll go to stage two. As I went to stage two, guys, you can see the second nearest neighbor. What is in the sense second nearest neighbor? Test took the data point which is nearer to it. Okay, so as you can see the lines which I have drawn. Okay, so which is all parallel, guys, and this one is only the thing which is nearer to you. Okay, the second nearest neighbor, and the remaining lines you can see it is way much more far. Okay, that is what about second nearest neighbor. And when you go for third nearest neighbor, guys, you can always see the line, the data point. You can always see it, which is very nearer to it. Okay, the nearest neighbor. So the first it took as this one, and second nearest neighbor is this, and the third most is this nearest neighbor. Okay. As we are seeing, guys, we'll be moving on further. Okay. So next thing we're going to see is 8 nearest neighbor. Okay, so which are the nearest neighbor? Just 8, right? So it has took 8 nearest neighbor. So you can see, guys, circles. Okay, it's going to take only the nearest neighbor, and you can see the points which I have drawn, which is it is far from the other points. Okay, you can calculate. So it has took the data set point has moved here, and you can see the data set has moved. Okay, so k nearest neighbor is nothing but they are going to take the point data points which are nearer to them. Okay, guys. So this was all about k nearest neighbor classifier. Okay, so it's going to take the nearest points. After that, we are going to see complexity. And after this, you can see, guys, to which class it belongs to. Does it belongs to class pink or does it belongs to class blue? So guys, it belongs to class C, which is which data points we have more pink, right? So it's belong to class pink. Okay. So next thing, we're moving on with complexity of K. So what is the complexity of K? So how we are going to control the complexity of K? So right level model of complexity. So we are going to see this. What is the accuracy? Okay, validation of the accuracy. So we are going to calculate this using KNN. Okay. So as we discussed, KNN had classification, okay, and regression, right? So what is KNN classification? So K nearest neighbor algorithm. K nearest neighbor algorithm. The K nearest neighbors, also known as KNN. Okay. KNN is also this KNN algorithm is a non-parametric supervised learning. Okay. Okay, so it is a non-parametric supervised learning classifier which uses proximity to make classifications or prediction about the grouping of an individual data point. So basically we are going to do non-parametric supervised learning for individual data point. Okay, so can be this KNN used for classification? The doubt arises. So you can see, so KNN is one of the simplest forms, okay, or this machine learning, it is one of the simplest form. We are going to use this algorithm mostly used for classification, as I said. Okay, so KNN classification, okay, that is nothing but a non-parametric supervised learning classifier which uses proximity to make classifications or predictions about the grouping of individual data points. So after that, we are going to see what is our sample data. So guys, we have sample data of ingredients. Okay, so we can see sweetness, crunchiness, and food type. So we are going to see the sample data. So here the crunchiness of food, okay, depends on what is the graph we have. And we are going to see what is our sample data. Okay, the proteins, vegetable, fruits. So we can consider here, guys, which belongs to proteins, which belong to fruits. Okay, so after that, we are going to go for sample data. So here, the tomato, as I said, guys, the K nearest neighbor is going to take the nearest thing. Okay, so here, what can we call this tomato assets that belongs to vegetables or proteins or grain? Okay, so guys, how the tomato is going to taste? Okay, so based on that, we are going to calculate K nearest neighbor. So K nearest neighbor is nothing but it's going to take the value which is nearer to it. Okay, so you can see the tomato is going to take for green bean, nuts, grape, and orange too. Okay, so you can see for vegetables, it's going to go for green bean. Okay, and tomato, it's going to go for nut, and it's going to go for orange and grape as well. So how it's going to taste? So it's going to category of fruits, guys. Okay, based on the crunchiness and the sweetness what we have for tomato, it's gonna go for the fruits. Okay, so we're gonna measure similarity with distance. Okay, so locating the tomato's nearest neighbor requires a distance function. So guys, as we said, we are using Euclidean distance as well as Manhattan distance. Okay, between centroid value and observed value is Euclidean distance. Okay, so we have seen this formula, right? X01 plus minus x square plus. So this is our formula, guys. Okay. So traditionally, as I said, we are going to use Euclidean distance for now. So using Euclidean distance, we have seen how we are going to use that. And after that, we are going to illustrate what is the previous dotted lines we have. So we can see tomato was connected to vegetables, proteins, as well as fruits too. Okay. So Euclidean distance, you can see the formula for Euclidean distance. Okay. So where P and Q are the examples to be compared, each having n features. Okay. So term P1 refers to the value for the first example of P, while Qn refers to the value of first features of example of Q. Okay. So that was of Euclidean distance, guys. So which class tomato belongs to the given features? So tomato sweetness was 6 and crunchiness was 4. Okay, you can see tomato sweetness was 6 and crunchiness was 4. The food type was, what was the food type of tomato, guys? Because food type was this, right? So if you ask me, what is the advantages and disadvantages of KN? So guys, advantages of using KN algorithm is, guys, it has no training piece. Okay, it can learn complex models easily. It is robust to noisy training data. Okay, so advantages and disadvantages we have for this KN is, one thing is it has no training phase. Okay, it can learn any complex models easily, and it is robust to noisy training data. And the disadvantages, it's a lazy learner. Okay, the lazy learner. So determining the value of parameter k can be difficult as different of disadvantages. Okay, it's hard to apply on high dimensional data. Computational cost is high, as I said. The computational cost is high. Okay, It go through all the record which take on point time, where n is the number of records. Okay. If we maintain a priority queue to return the closest k record all time of the complexity, then the log of k star will be okay. Okay. So these were the advantages and disadvantages of KNN. Okay. So this advantages. Okay. So the next thing is it is easy to understand. You can go with this point. Okay. It is easy to understand and simple to implement. Okay. Easy to understand. So as I explained this, it is nothing. It's going to take the nearest value. Okay. And it is easy to implement. So what we are going to do, we are going to take the observed value and actual value. So we are going to apply that and we are going to get the root of that and we're going to implement. Okay. So it is used for both classification and regression too. Okay. It is ideal for non-linear data since there is no assumption about underlying data. It can naturally handle multiple class cases. Okay. It's natural for this KNN to handle multiple this classes. Okay. So after that, so if you ask me, sir, after saying all this example, so which is important? So is KNN or K-means? So the main difference is that KNN is a supervised machine learning algorithm that is used for classification tests. Okay. And K-means is an unsupervised machine learning algorithm used for clustering. As I said, it is used for both regression and classification. But if you ask me, they are better in their type cells. Okay, which is better, KNN or K-means? If you ask, the main difference in KNN is a supervised machine learning algorithm. It is used for classification, and K-means is an unsupervised learning used for clustering. You guys, so this is what is the major difference. And if you ask me, what is KNN model used for? So K nearest neighbor is also known as KNN supervised learning algorithm that can be used for regression as well as classification problems. Okay. Generally, it is used for classification and it is used in machine learning problems. So what are the limitations of KNN? So if you ask me, what are the limitations of KNN? Okay. The limitations of KNN are space complexity. Space complexity. Okay. We have space complexity. It refers to the total memory used for the algorithm. Okay. If we have n data points, okay, in training at each point of this m dimension, okay, this is going to take huge data where we have higher dimension. Therefore, KNN is not suitable for high dimensional data. Okay. Why this KNN is called as lazy? Right? Someone will be saying why KNN is called as lazy. So guys, why it is called as lazy? Because it does no training at all. When you supply training data at training time, all it is doing is storing the complete data, but it does not do any calculation at all. Okay. So when should we not use the KNN? So it does not work well with large data set. Okay. Since KNN is a distance-based algorithm, the cost of calculating distance between a new point and each existing point is very high, okay, which in turn degrades the performance of an algorithm. Okay, so first thing is it does not work along good with large data sets. And next thing is, since this KNN is a distance-based algorithm, the cost of calculating distance between a new data point and existing point is very high, in which it degrades the performance of algorithms. Degrades. Okay, degrades performance of algorithms. Okay, so we have seen this. Okay, so next thing we're going to see is two types of the tests: classification and regression. Okay. The key differences, KNN regressions try to predict. Okay. KNN regression tries to predict value of the output. Okay. KNN classifications KNN classification attempts to predict the classes of each output. Okay, it's gonna attempt to predict class to which output variable it belongs. Okay, so this is regression and classification. It's the difference of this. Okay, so if you ask me, it is a regression or classification. It works for both. Okay, so how does this KNN work for regression? Right, you can ask me, how does this KNN works for regression? Okay, so KNN regression is a non-parametric method that in an initiative manner approximate the association between independent variables and the continuous outcome by averaging the observation in the same neighborhood. Okay, approximate is going to approximate the assumption between independent variables and the continuous outcome by averaging the observations. Okay, can classification and regression be used together? Okay, that's a valid question. So fundamentally, guys, classification is about predicting, right? So classification is about predicting. So we have seen this. So what it is going to predict? Predicting a label and regression. Okay. So the main reason for the predict values are continuous, not probabilistic. Okay. So we can't get an exact class to accomplish the classification. So how do we know that is a regression or a classification is KNN? The most significant difference in regression versus classification is that regression helps to predict continuous quantity. Okay. Regression helps to predict continuous quantity. And it's gonna classification, it's gonna predict discrete class labels. Okay, there are some overlaps between the two types, guys, for this machine learning algorithm. We have regression and classification. So why is KNN better than this regression? You can ask me. Okay, why is KNN good for classification? The main advantage of KNN over the other algorithm is KNN can be used for multi-classification. KNN can be used for multi-classification. Okay, the KNN is for multi-classification. And why can't we use regression for classification? Right. So regression is not suitable for classification. The first one is that linear regression deals with continuous values. It's going to deal with continuous values. And whereas classification problems man-made discrete values. So it's going to go for discrete values. So these are the main differences. Okay. So which algorithm can solve this both regression and classification problem? If you're going to ask me, it is SVM. Okay. If you want to solve both regression and classification problem, we're going to use SVM. Okay. To solve that both classification and regression problem, we are going to use SVM. Okay. is nothing but support vector machine. Okay, so the advantages of using this KNN we have seen, and we have seen the disadvantages of KNN algorithm too. Okay, so when should we not use that? We should not use that when we have a large data set. Okay, when we have a large data set, we should not use KNN. Okay, so moving on, will we see the different slides what we have. Okay, we have genetic algorithm. So what is this genetic algorithm? So the genetic algorithm is a method for solving both constrained and unconstrained optimization problems. Okay, that is based on natural selection, the process that drives biological evolution. Okay. So what is this genetic algorithm we have seen? The genetic algorithm is a method for solving both constrained and unconstrained optimization. Okay, that is based on natural selection. Okay. Perception. Okay. Okay. So we are gonna see K in automative analytics. That's all. Okay. So in automative analysis, the car companies is gonna analyze their existing customers. So they're gonna identify characteristics that gonna predict a purchase. Okay. Comparative cross-validation involves estimation accuracy. Okay. Okay. It's gonna stratified k-fold cross-validation. We're gonna equivalent repeated random sample. Okay. So these things we are gonna see. So notice KNN in automative analytics. Okay. While the purpose methods. Okay. We are gonna see high bias. So is the performance. So we're gonna see its performance accuracy estimation, and we're gonna see what is the poor performance due to high variance. Okay. As I said, that's the accuracy. Okay, the accuracy with proposed k nearest neighbor classifier was less than that the existing k nearest neighbor. So while we drag on to the code, guys, we're going to see how we're going to use k in automative analysis. Okay, so this was the k in automative analysis. So in automative analysis, the car companies are going to analyze their existing customer to identify characteristics. Okay, that's going to predict a purchase. And comparatively, the cross validation, we're going to see the estimation of the accuracy by the k-fold cross validation. Okay, and we're going to do random subsample. So after that, we're going to see what is our conclusion. Okay, so what is the conclusion using this KNN? So KNN is one of the many lazy learning algorithms. Okay, is one of the many lazy learning algorithms that does not based on predictions. Okay, based on prediction on a learning model. And KNN makes predictions on the fly, okay, by averaging similarity between an input observation that data already is present. So KNN is going to make prediction on the fly. Okay, it's going to take an averaging similarity of an output and the observation and the data already present in it. So these were the conclusion of the KNN in automative analytics. So when we go to the code base, so you can see what are things we're gonna see. Okay. So KNN is one of the most simple algorithms in supervised learning. In this example, we shall see how to classify and predict cars using the KNN algorithm. Okay, KNN is nothing but one of the most simple algorithm in supervised learning. Using this example, we shall see how to classify and predict cars using KNN algorithm. So first things what we are going to do when we are going to apply KNN, importing the necessary libraries using the Python. Okay. The first thing we are going to do is we are going to import the libraries which are necessary for us. Okay. The Python come with 3 environments. Okay. Maybe helpful for the libraries which we have installed. Okay. So we are gonna import the libraries. Yes. Import numpy as np. So it is nothing but the linear algebra. Okay. So numpy, which is basically used for linear algebra. So these are libraries what we have as import numpy as np, import pandas as pd. So these are libraries what we have. So we are gonna import pandas as pd, data processing, CSV file. So for data manipulation, so we're going to use pandas. So these two things, what is present inside the Google Colab, this is called as a cell. This whole thing is called as a cell. So in the cell, we have imported numpy as np, that is nothing but a linear algebra, and we have given import pandas as pd. Okay, import pandas as pd. And after that, we are going to use sklearn nearest neighbor to import k neighbor classifier. So guys, as we know, we are going to use k nearest neighbor classifier. So from sklearn.neighbors, we are going to import this nearest neighbor classifier. After that, we are going to use the KNN algorithms. Okay. So we are going to use KNN algorithm from sklearn.model selection. Okay, we are going to import train and test split. So we have seen, right, how the train and test is going to work. So how much data we are going to send it, we are going to see if that is good, it's a right fit model. And if it is low, right, train and test guys. Okay. Both are high in performance, that it is called as a right fit model. Okay, if train is low and test is high, then it is overfitting or variance. Or variance. Okay, if both are low, then we're gonna see the form of underfitting or bias. Okay, to solve this, what we're going to use to solve the overfitting, we're going to use regularizations. Okay, so we're going to use regularization, which fits data into a model. Okay, and underfitting or bias, to solve this, we are going to transform the data. Okay, the same thing what we are going to do here is, so this was one thing guys. So after that, we have imported sklearn.metrics, the library. We have imported sklearn.metrics. We are going to import confusion matrix. Okay, so after that, we are going to import confusion matrix to classification report. And we are going to, from sklearn, the pre-processing, we are going to import this. From sklearn, we are going to import pre-processing. Okay, so after that, we are going to read our data. We are reading the data set. So I have given the variable name as card. So I'm going to read my data set. So I'm going to write pd.csv. So in the last time we had Excel. So whenever I have data sheet as Excel, I'm going to write here as Excel. Okay, so now it is CSV. So I'm going to write as CSV. The file is CSV. So if I have Excel, I'm going to write it as pd.read Excel. Okay. So these things we are going to do. So after that, we are going to check the data set. Okay, cars dotted, it's going to be first 5 values. Okay, the cars dot head, it's going to give us the first 5 values. Okay, so I can see the models of car what we have, these things. Okay, and MPG and the cylinders, how many cylinders we have for the cars, the model cars, and the horsepower. Okay, so gear. So all these things, what is necessary to have in a car. So we have that things list. So we have model, MPG, cylinder. Okay, so these things we have. So after that, we are gonna check if we have some missing value. So here, guys, what I have done, in the KNN, as I said, is one of the best algorithm used for supervised learning. We are going to see how we are going to classify the predicting cars using this KNN algorithm. So we are going to import NumPy as LP. We are going to import pandas as PD, the libraries which is required for that. And after that, we are going to import K nearest neighbor classifier things. Okay. And from sklearn.metrics, we are gonna import train and test splits. Okay, we're gonna split our data using train and test splits. So we're gonna split our data into train and test. Okay, so after that we're gonna do pre-processing. So in my data, I'm gonna read my data using the CSV. So it is my CSV file. So after that, I'm gonna run my cars.head. So this it's gonna give as the first five values what we have. Okay, the first five values what we have. So in our data set, and after that, I'm gonna check if I have any missing values. Okay, after that, I'm gonna check if I have any missing values in my data set. So cars.isNull.sum. So we can see is there any null data set? It's gonna give us. And what is the data type? The data type is integer of 64. Okay, so here what I have done, I have checked what is the if I have some missing values or not. So here what we did in the upper side, you can see we have got the head. Okay, so first five values. To get that, what we have done, we have loaded our data, we have imported the libraries which is necessary to run the data, and we have seen the data set. Okay, and we have checked there is any missing values, and I'm gonna see x is equal to cars dot. So I have MBG what high horsepower gear and meter. So I'm gonna train my data using this guys. So training my data using these things. Okay. The first is training guys, and why is testing? Okay. So train and test. The split we have done. Okay. For training, I have sent all the data. Okay, what we have. And for testing data, we have some this. And after that, we have done pre-processing of scale. Okay, we have done pre-processing of the scale. So in the sense, what I have done, I have splitted my data. So you can see X train, X test, Y train, Y test. Okay, I have done the splitation of data. I have splitted my data and have given the size 0.3 and the random statistic. So what I have done here. So here I just splitted my split the training into this data set into train and test, and I'm gonna see what are the data cycles. So why train first only learns the data? Because it is gonna do some mathematical equation, and the data is first into the train, right? That is the reason it's gonna learn some mathematical equation. Okay, and after doing splitting of train and test data, I'm gonna see what all the splits I have. Okay, so I'm gonna check the train data set size too. So after that, we are gonna see what is the we are gonna check the train data set size. Okay. The train dot shape, okay, is 22, okay. So checking the train data set size, we have 22, okay. That is the size of our train and test data. Okay, so after splitting the training test data, this thing we are going to do is we are going to train the model. So train the model, what we have, we are gonna do K neighbors classifier. Okay. K neighbors classifier. So I'm gonna train the model. Okay. So after splitting my data into train and test, okay, X train and Y test. I splitted my data. Okay, after splitting my data, I'm going to train the model. Okay, so training the model I have done. So after that, I'm going to fit my training data into X train and Y train. Okay. And K neighbors classifier is the what is the nearest neighbor we have. Okay, so what we're going to use this K as K neighbor, K nearest neighbor, K nearest neighbor classifier. Okay, so we have done that. So we are going to see which is the nearest value. And after that, what we are going to do? We are going to see we're going to fit the model. We're going to fit our model. Okay. Okay. So, yeah. So we're gonna train the model. Okay. So we're gonna train the model. After that, we're gonna after training the model, we're gonna fit exchange and binary. K nearest neighbor classifier, the M neighbors we have. Okay. So after doing that, I'm gonna do the prediction. Okay, what is the prediction, sir? So guys, what is the prediction I'm gonna get? So I'm gonna do the prediction for the Y data set. Okay. Y train data set. Okay, so Y is for test guys and X is for train. We know that I'm gonna do the prediction. Okay, so which thing we are gonna get? So KN is we're gonna get the nearest neighbor thing. Where I'm gonna check the model accuracy. What is my model accuracy? So I'm gonna use the confusion matrix. Okay, I'm gonna go for text and Y predict. So I'm gonna predict the models what I have. Okay, I'm gonna do confusion matrix and I'm gonna put the array of 6 and okay, and I'm gonna print my classification report. Okay, I'm gonna print my classification report. I'm gonna say what I have predicted for Y test and I have got the precision F1 score and F1. What is my accuracy? And this is the what is the accuracy of so what is the efficiency I have received is 93%. Okay, with this I have achieved an efficiency of 93%. So what is okay? So what I have done, I have what is meant by KNN, the group neighbors guys is the number nearest neighbor we're gonna calculate. Okay, we're gonna calculate the nearest neighbors. Okay, we're gonna calculate what is our nearest neighbor. Okay, so we're gonna calculate neighbors which are nearer to us. After that, I'm gonna import the libraries. So after importing the libraries which is necessary for KNA, I'm gonna do sklearn.neighbors. I have imported that and I have imported KNN algorithm. Okay. And from sklearn.model, I have imported model selection. Okay. After importing all the libraries, I have done the things which is necessary for us. Okay. From sklearn, I'm gonna import pre-processing and I'm going to check what all the data set I have. And I'm going to check if there is any isnal values. Okay. And after checking isnal values there, I'm going to go for, I am going to train some models. I'm going to test some models. Okay. After training and testing some models, after that, we're going to check the train data set size. Okay. And I'm going to do the KNN neighbors classifier. Okay. After doing KNN neighbors classifier, I'm going to see the data points which is necessary. Okay. And what I'm gonna do, I'm gonna check the model accuracy here, guys. Okay. Here I'm gonna check what is my model accuracy. So I'm gonna print my data. Okay. Printing my data, I'm gonna do the classification. So after doing the classification, you can see with this, I have achieved what is my efficiency. I have achieved an efficiency of 93%. So KNN is all about this. So it's gonna take the nearest neighbor things, guys. So what it's gonna do, it's gonna take nearest neighbor classifier. So what was our agenda? So let me show you once. So guys, here you can see the agenda was of KNN was introduction, that is done. KNN machine learning. So we have seen how it is gonna useful in this machine learning, right? So we have seen this. So we have seen this and what is the importance of automative analysis, right? What is the importance of automative analysis we have seen and the conclusion also we have seen this. So these agendas, okay, we have seen what is our agendas. Okay, so if you go to the slides once, so the introduction is done. See, we have understood what is the introduction. We have seen what is KN in machine learning. Okay, and we have seen why do we need machine learning is KN, right? So to which class it belongs to? If that belongs to class A, will that belong to class B? So we have seen that using KN in algorithm, and after that we are gonna go for KN in automative analysis. So how this KN in machine learning algorithm is useful in KNN of automative analysis. Okay. So after that, we have come to a conclusion. Okay. So what is the conclusion we have got? KN is one of the many lazy learning algorithms that don't base prediction on learning model, guys. So this conclusion also we have come, and this KNN is going to make the prediction on the fly. Okay. It's by just by averaging the similarity between an observation and the similarity of this the data which is present. So these things we are gonna see for this. Okay. So this was all about KNN classifier. Okay. So we have seen this. So what we have seen. So we have seen what is we have understood what is meant by KNN classification, and we have seen what is the use of that. Okay, and how we are gonna implement KNN. Okay. So what is the use of KNN we have seen. So guys, after that, we have seen what is the use of these things. Okay, so how we're going to implement how we're going to implement the KNN in this automative analytics. So what is the use of that? So we have seen the libraries which is important to load and to work on KNN. Okay, so this was all about KNN, guys. Okay, so I'll be ending the session of KNN for this. So we'll be connecting tomorrow for the other regression, guys. Okay, we're gonna do it further. So make sure it'll be available for next. Thank you, guys.